In this video we're going to look at the central limit theorem. It's really interesting. Just want to look first at the normal distribution, okay? Remember I said to you a while ago that a lot of data takes on this normal distribution. So for example, there's the shape of the normal distribution and it's symmetrical. And if I got the heights of all the people in a room, well, most of them would be in the middle here, okay, an average height. But then there'd be some tallish people here, some smallish people here, and then there'd be even less, a very small amount of really, really tall people and a very small amount of really, really small people. And that's the normal distribution, okay, it's that shape. And if we have data with the normal distribution, then we can do a lot of tests on it, right? We can do confidence interval and hypothesis tests and their z-scores and looking at the probability of getting more than or less than a given z-score. However, not all data has that normal distribution. If you look at this one, a sample of children were asked what age they learn how to ride a bike at, and the data shows what way they answered. Now this shape, this is not in the normal distribution. If we look, so we look here, it's actually very much skewed to this side, okay, so there's a positive skew on it. So, and that would make sense. I mean, I suppose most people would learn how to ride a bike when they're young, maybe 3 or 4. The very odd few might learn how to ride a bike up at 14 or 15, and virtually no one would learn how to ride a bike at 1. Okay, so that makes sense that it's not normally distributed. The problem is, if the data is not normally distributed, well then we can't perform these tests on them, like the z-scores and things like that. Okay, we can't perform any of those tests on a distribution that's skewed. But all is not lost. Okay? The central limit theorem, well, that states that the distribution of sample means approximates to a normal distribution as the sample gets larger and larger. Right. So here's what I mean by that. So let's say I look at this data here, okay, and let's say, I don't know, 10,000 people were surveyed. And I decide to take smaller samples of that 10,000, right? So there's 10,000 people surveyed for this. They give us this data. It's not normally distributed. So then I decide, okay, I'm going to take samples of 50, right, from this 10,000 people. So I'm going to take a sample of 50 and I'm going to check what their mean is, right? So take the sample of 50, add them all up, divide by 50, see what the mean is. The mean age that that sample of 50 learned to ride their bike at. Then I'll take another sample of 50 and I'll check out what their mean is, and then another sample of 50 and check out what their mean is. Well, if I get 100 samples of 50, checked out what all their mean is, and then put their mean on a graph, I would get something like this. Slight shape to it, okay? Not that obvious, okay? But there is a slight shape. There's more of the means at what, 4, 5 maybe, less data have a mean of 6, maybe a few of 4. Now let's say I start again and I take a sample of 1,000. Okay, so that means is I take samples of 50, right, but I do it 1,000 times. So take a sample of 50, check out what the mean is, take another sample of 50, check out what the mean is, do that 1,000 times. So I get 1,000 means and I plot it on the graph. And here we go. Again, it's showing us kind of a certain type of a shape. So most of the means that I've got are around 5, 4 and a bit, 5. Some of them up here, some of them down here. Now let's say I went a step further. Let's say I took a load of samples, right, of 50. Okay, so loads of samples of 50, checked out what their mean is, and put it on a graph. Let's say I took this many samples of 50. So take a sample of 50, check what its mean is. Take another sample of 50, check what its mean is. Take another sample of 50, check what its mean is. I did that 1,000,000 times. And I plotted them on the graph. That's the shape I get. Now we know that shape. That shape is the normal distribution. Okay? So what we're saying here is Above we can see that if we take a big enough sample, calculate all their means and put the data into a distribution, the distribution that emerges is the bell curve, the normal distribution. Now we can carry out confidence intervals on this data. So now we couldn't do anything with this, right, because it's skewed, but we can do some, I suppose,